I have not checked your attendance. 19.
Ma'am, could you invite Muzammil? Can't see the meeting.
Start others. Can you see the slide? The slide presentation. So water rises in a capillary tube up to a height of, so I'll take water separately. So the height of the water, H1 is 9 centimeter, so 9 into 10 to the power of minus 2 meters, while mercury, your H2 is negative, minus 3.4 centimeter, that is minus 3.4 10 to the power of minus 2 meters. The same capillary tube, which means the radius will be the same. Assume the angles of contact for water and glass. Sorry, for water and mercury. Water glass, mercury glass is 0 degrees and 135 degrees respectively. So here theta 1 is 0 degrees. Here theta 2 is 135 degrees. So that becomes, okay, fine. So I can write this as 180 minus, how much I'll go for it? 45? What is the value was? 180 minus 35. 45? 11B.
Yes, ma'am. It's 45.
Okay, cos of 180 minus 45. What is the value? Minus cos 45?
Yes, ma'am. They given it as minus 0.71.
Okay, it's given. But in case if it is not given, how will you do this, boys? Mine is 1 by root 2. So how will I find this? Root 2 by root 2. So, sorry. Fine. This value will be minus root 2 divided by 2. So what is minus root 2? 1.414 by 2. So minus 0.71 approximately. That is theta 2. Now the question is, the density will be the same in both the cases. Sorry. Density will be, they have not specified the density. Take rho 1 is equal to 10 to the power of 3 kilogram per meter cube. Density of mercury rho 2 is equal to 13.6 into 10 to the power of 3 kilogram per meter cube. Only thing, what is G will be the same radius, because same capillary tube. So R1 and R2 will be the same. So the general formula is, yes, formula is H is equal to, what happened? What happened?
Keep the density of mercury.
No, density will also be provided, boys. But in case of water, in some cases, in some questions, the density of water might not be specified, but density of water you should know. 10,000 kilogram per meter cube. The rest they will provide. So you have all these data. So just find what is T1 by T2. Just find T1 by T2. Derek, Samuel, Vishesh, Derek, Samuel, Vishesh.
I'm finding out.
Okay. I heard from Vishesh. Where is Samuel? Samuel is absent today.
It looks like Sam's having some connection issues.
Okay, Surya. Surya there. Kritya.
Yes, ma'am. Yes, ma'am.
Okay, fine. Kritya.
Yes, ma'am.
Okay. Let's just calculate, boys. T1 is to T2. What's the answer? Did anyone get the answer? Should I do, or will you be able to do? The radius in both the cases will get cancelled off. Acceleration due to gravity, g also will get cancelled off. The rest will be there. So get an expression for T1. So T is equal to h r rho g by 2 cos theta. Then you go for T1 by T2. Did anyone get the answer, boys, over here?
I approximated it multiple times and I'm getting
Approximately? Is that 1 is to 7.2? Something like that?
I'm getting 0.14. 1.4 into 10 raised to minus 1.
Okay. Ratio is, your answer is T1 is to T2 is, what was your answer?
Ma'am, 1/4 divided by 100. 1/4 by 100. That's the ratio.
14 by 100?
Yeah.
Which
Got it in
means,
decimals. So.
okay, fine. Let us see. So 0.14 is to 1. You had gone for T1 to T2, correct? Anyone else who has got the same value? Shakshal, what is the answer? Yusuf? Yusuf?
Yes, ma'am.
Okay, what's the answer, Yusuf? Still calculating? Okay. Shamshul? Boys, you're taking a long time to complete a numerical. Austin, Ayan, Austin and Diane. Eleven B.
Yes, ma'am.
What is that you have
Yeah.
arrived at? Okay. T1 by T2. What's the value you plug it in? It's max. Your students have mathematics as your the other subject. Then why it is difficult for you to solve was? Why is it taking a
Like
long?
decimal multiplication, or it takes bit time. That's all.
Adam? Hitesh? Hitesh? Samuel is here. Okay, fine. He has written in this chat box. What about Hitesh? Such a long time. Now, are you able to calculate? Or should I do?
No,
Should I
it's
go
fine.
for?
I think we understood the concept here. We can go to the next question now. We can do the calculation afterwards.
Okay. Now this comes as a part of your 5-mark question. In case if this question, the question based on the concept of capillarity comes for your examination. Out of 5 marks, 3 marks might be for deriving the Ascent formula. Might be the next 2 marks.
Ma'am,
It
could
can
you
be
tell
a
the
numerical
answer
based
to the
question.
previous question again, please? Okay, ma'am. Thank you.
Just have a cross check, boys. So it might be a numerical for 2 marks, or it might be the rise of liquid in the capillary tube of insufficient length. Now, what is that? Suppose if I have a capillary tube, say of uh, length L. So let me take a capillary tube of length L. Now when this capillary tube of length L and radius R is being dipped in a liquid, you know, because of capillary action, the liquid will rise in the capillary tube to a height h. Suppose I have another capillary tube, but it has insufficient length. The length of the capillary tube is very less compared to the previous one. The other dimensions are all the same. Only thing is that the length of the tube, say L dash, is less than the length of the previous one. Then naturally what we think is that as the liquid begins to rise in the second capillary tube, because of its insufficient length, there might be an overflow of the liquid. But that is not really happening. What is going to happen? In a tube of insufficient length, the liquid will rise to the top of the tube and then starts spreading till the liquid is in equilibrium. This is what is going to happen. So when you take 2 capillary tubes, other dimensions, the density of the liquid, everything are the same. Only the length of the tube, both the tubes are different. So naturally what happens in the tube which has insufficient length, the liquid will rise to the brim of the tube and then it starts spreading out. It means its radius of curvature will readjust itself. Now we'll see how this is going to happen, right, boys? The heading is rise of a liquid in a tube of insufficient length. So of this 5-mark question, might be 2 marks will be allocated for this. Rise of liquid in a tube of insufficient length. And then you can start writing this. What is going to happen when a tube of insufficient length is dipped in the same liquid? The liquid will rise to the top of the tube and then it starts spreading, readjusting its radius of curvature. We'll see that. So heading will be rise of a liquid in a tube of insufficient length, and then you can start in a tube of insufficient length, the liquid rises up to the top of the tube and starts spreading till the liquid is in equilibrium. So you can have both the diagrams. So R is the radius of curvature of the liquid meniscus in tube 1. R dash is the radius of curvature of the liquid meniscus in tube 2. Copy down, boss. Dheeraj.
Yes, ma'am.
So you can initialize everything. Initializing the capillary tube of radius R, open at both the ends are dipped in a liquid of density rho and surface tension T. So both the statement can be combined together. The height h to which the liquid rises in the tube, the first one is given by h is equal to 2 cos theta divided by r into rho g. So these first two statements you can combine together.
Ma'am, we should draw both the diagrams, right?
You need to draw, boys. So you are considering a capillary tube of radius r dipped in a liquid of density rho and surface tension T. The height h to which the liquid rises is given by the formula h is equal to 2t cos theta divided by r into rho into g. So this part statement is important. Finish it out. Boss, shall I go for the next one or you need time to complete this? Boss, shall I go for the next one?
Ma'am, we need time to complete.
Okay. Can someone put this in the chat box, boys? This diagram. Is it possible for you people to copy the diagram later? Or you want to do it right now?
Ma'am, we'll do it right now.
Okay.
Ma'am,
Yes.
once the liquid falls out, shouldn't it like be a continuous process?
No, it will not fall. That's what it's being stated that it rises to the top of the tube and then it spreads out. Only what it does, it will change its radius of curvature. That rearrangement will be done by itself until it will spill out. Once its radius of curvature becomes plane, its radius of curvature keeps increasing. R dash will be greater than R. So till the liquid can have a concave meniscus, it spreads on to the top.
Understood. Ma'am.
Once it becomes plane and more than that, it will spill.
Ma'am,
Yes,
no, should you write the statements also?
statements are important, boys.
I'll just take a screenshot.
Okay,
Yes, ma'am. Done.
fine. As usual, as what we have done in the previous case also, we are talking for the cube 1. So in this triangle theta, this is R and this is your R. So you can go for I think so. Last derivation, we have derived an expression for R. So R is equal to R cos theta. So let us substitute the value of R in the previous one. What was that? H is equal to 2t cos theta divided by R rho G. So when I'm substituting this, this becomes 2t cos theta divided by R cos theta because I'm substituting for R. So R cos theta into rho G. H becomes equal to 2t by R into rho G. Right, boys? So now what they have done is that they have taken R to the other side. So R into H becomes equal to 2t divided by rho into G. Guys, are you clear how we are arriving at this expression? So R is the radius of curvature of the liquid meniscus in tube 1. H is the height to which the liquid is rising in tube 1. The same thing will happen for tube 2 also. Same thing will be for R H dash will be equal to 2t by rho into G. Now, what is T? T is the surface tension of the liquid. So in both the tubes, the liquid is going to be the same. So the surface tension T will be the same in both the cases. The density will also be the same. Acceleration due to gravity will also be the same. We obtain this RH is equal to 2T by rho into G. Have you completed this, boys?
No, ma'am.
If you can write, you can write similarly. Was we are substituting for R as R cos theta. That clear, boys? So you'll get R into H is equal to 2T divided by G, rho G. Shall I move for the next one, boys? Once you have completed, just remind me. Shall I go for the next one?
All right, ma'am.
One more thing, what we can do is, this is what I'll mark this as equation 3. Now I can go for tube of insufficient length. The second one. For the second one, we will still have R dash H dash will be equal to 2T by rho into G. So now this becomes equation 4. Are you clear, boys? Are you clear?
Yes, ma'am.
Yes.
Okay. Now I'll change the. Now compare equation 1 and 2. Sorry, 3 and 4. Comparing equation 3 and 4. Right hand side are the same. Was is that the right hand side of equation 3 and 4 are the same? So left hand side should also be okay. R into H must be equal to R dash H dash. So what I can do is H by H dash will be equal to what? H by H dash will be equal to R dash by R. Is that correct, boys?
Yes, ma'am.
Okay, now you very well know since H is greater than H dash, therefore R dash will be greater than R. It means your liquid will spread out so that its radius of curvature will increase in case of a tube of insufficient length. So this is the key point. R dash is greater than R. Should I redo this, boys? Dheeraj? Johan?
Ma'am, it's fine if you don't redo it, but could you show the statements, like the text statement?
Okay, next page. Okay, next slide. I'll go for it. So just complete this theory. Sorry, derivation part. For the statement, I'll go for the next page. Next slide. Shall I go for the next slide, boys? So someone take the screenshot and put it in the chat box so that I'll move for the next one. So now you can write this one. The radius of curvature of the meniscus, the liquid will not overflow. So since H is greater than H dash, R dash is greater than R. Was your class started? The next class?
No, ma'am, in 3 minutes we have break.
Okay. Let's complete this course. That's it. Okay.
Ma'am, can we leave if we have completed the statement?
One second, boys, 1 second. Just only 1 second. I'll just introduce the next chapter. Just an introduction, that's it. Boys, it will be the second last chapter, oscillation. So under oscillation, this is what you are going to study. Periodic motion, time period, frequency, displacement as a function of time, periodic functions. Then simple harmonic motion, oscillations of a loaded spring, energy in simple harmonic motion, kinetic and potential. So these are the things that you will be learning in oscillations, then later on in waves. So I think so you know what is oscillatory motion. We'll start that in the next class. Fine, you can, those who have completed can do.
Thank you, ma'am.
Thank you, boss.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Just thank you, boss. Just